So, hello everyone. I hope all of you are well and good and giving your 100% to your study. And obviously, after today's lesson, you will enjoy maths much more. Okay, so as you can see, uh, a cube is rotating in the skin. Okay, so today we'll start the lesson with boxing and unboxing concept. As you have seen, my channel name is Maths Magic. So I will always try to show you something different. You have seen different types of videos, but I will try to use this digital platform completely. Okay, I will try to give my 100% to clear your concept digitally. Okay, I need your help, your assistance, so that I can give my 100% that I have learned this last 10 years, and I can deliver you within a nutshell. Okay, so thank you all for watching. Let's start today's videos. Today we'll to start our lesson by unboxing this cube. Okay, here we go. Let's see. So yes, you can see the cube. Yes, so I will show the network of the cube. Okay, you can see this. I'm just unboxing it. Okay, here you go. Yes, it's just like a means satellite launching. Okay, you can see the figure. So nice 3D concept is here from different sources. I'm collecting all these things for you people only. I hope you will enjoy it. Okay, so let's start. Today in this video, what we will do, we will learn the how to find out the surface areas and the volume of different 3D surface. Okay, so you can see this is a cube. It has how many faces? It has 6 faces, and in case of cube all the faces are in shape of square, right? So we'll try to find out the areas, surface areas, and the volume of the cube. I'm just showing you the 3D concept. You can see this. If you see the network of the cone, cube and cuboid, then this type of 6 surfaces you can see this. Okay, if you take cuboid, then the surfaces will be rectangular shape. At least 2 surfaces may be square shape. Okay, so now you tell me that yes, what can be the surface area of a cone or a cuboid. Okay, so one by one 3D videos I will animation I will show, and I will then explain the surface area of it. Okay, so let's start. So you have seen already the network net 3D net of cube, or you can say cuboid or cube in the animation. So now we'll try to find out the surface areas and the volume of this cuboid. Then we'll find out for um, cylinder, cone, sphere, and all. Okay, so let's start. So you can see this is cube, because all the surfaces are in the shape of square. Okay, so suppose each side is a, so you can see there are uh, six surfaces. So for each surface, area will be what? Area will be side into side in a square, so that is a into a, that means a square. So how many? I'm talking about cube. Okay, then cuboid. So you can see total surfaces are 6. You have seen the network, so 6 surfaces there are there, and each surface area is a square. So what will be the total surface area of cubes. So first, number one is total surface area. So what will be total surface area? Six surfaces, and each surface area is a square. Okay, a square. So total six surfaces area will be 6 a square. You understand me? 6 a square. Okay. One more thing, the surfaces or the faces which are uh, if you exclude the top and bottom surface, if you exclude the top and bottom surface, then these other four surfaces which are sideways are in the side, four sides. Okay, left, right, front and behind, these four sides. So these surfaces surfaces, four faces, front, back. Okay, I'm gonna give you different trying to give different color. Okay, just a second. Yes, excluding these two, in the top and the bottom surface, there are four different surfaces. Okay, I can show you this animation. Yes, you have memorized, you have seen the animation. So uh, four surfaces you can see. These four surfaces are called, the sideways surfaces are called this, which one, lateral surface. Okay, for example, this means right side, left side. Okay, and front face. Yes, this front face, and the back face, and the this back face. Yes, so this back face. So four faces are there. These four faces are called the lateral surface. Means except this top and bottom, these two surfaces are known as what? This lateral surface. So if I want to find out the area of total surface area, 6 surface, that means 6 square. If I want to find out the area, lateral surface area, so that means lateral surface area, then this will be four surfaces, so it will be 6 into a square. In the case of cube, not in the cuboid. Cuboid we'll discuss just now. So we have got total surface area 6 square, and lateral surface area is, sorry, this will be 4 lateral surface, 4 faces are there, so this will be 4 square. Okay, this will be 4 square. Yes, this will be 4 square, 4 square. All right, yes, 4 square. Fine, because this bottom is square and the top is also square. This two faces is square, right? So 6 square minus 2 square, we will get 4 square. So this is total surface area and lateral surface area. Most of you know all these things. Okay, so next thing is that, but I am trying to explain with a 3D figure, 3D animation, so that it will be so realistic that you will be maths what lover. Yes, that is my actual target. Chalo, let's see. So now if I ask, these are area. Okay, now if I ask that what will be the longest rod that can be placed inside this. Okay, now tell me. So longest rod means what? Actually, the the diagonal. Now if we want to find out the longest rod, then what to do? First you find out the diagonal of this base. Okay, then this one, right? If we talk about this one, cuboid, for cuboid, I'm just drawing the cuboid once again. The longest rod for can be keep, just a second, longest rod that can be placed inside a cuboid. If you want to find out the longest rod, then first you have to find out. I'm drawing one rod here. Yes, from this to this, right? Okay, and from this to this, and this one. Now tell me, in case of this cube, it's all right. Okay. If you take this cuboid, then you will get length, breadth, and height. So what will be this length? This diagonal length. This diagonal length, you know this. If it is a rectangle, it is L. This is breadth. Then this will be what? This will be root over L square plus B square. Okay. So this side is root under L square plus B square. Okay. This side, and this is H. So what will be this one? This is in 3D space. Okay, not two-dimensional space, three-dimensional space. So it will be what? Again, under root this L square plus B square, it whole square plus A square. So if you remove this, if you remove this, if you simplify this, then you will get is this root will be removed, this one. So you will, it will be L square plus B square and A square. Got it? So the diagonal will be L square plus B square plus A square. Okay, root under L square plus B square. So this is the formula of longest chord. Okay, it is my humble request, you will keep patience and don't skip the video. Slowly you try to understand each and every concept. You know this, that it is a little bit difficult to explain in this digital board, digital platform, but I am just trying to give my 100% to you people. Okay, so keep patience and try to understand and try to relate the bookish knowledge with your real life. Okay, sure. So this is the longest chord. So all about this is all about the length and area. Fine. Now we'll find out the volume. Okay, we'll find out the volume. If I talk before going to the volume, if I ask you, then now you tell me what will be the total surface area of total surface area of cuboid, then I hope you can tell now. So total surface area and lateral surface area. First you have to find out lateral surface area. In case of cuboid, you can see uh, once again I'm drawing the figures. So number one, lateral surface area. This is L, this is B, and this is H. Okay, this is also L, this is also B, and this is also H. So what will be the area of this surface? Which one? This surface. Okay, this surface. Area of this surface will be what? You can see this, that here is B and H, so this will be BH. Okay, so this is BH. Similarly, it opposite face will be also BH. If you see the bottom surface, then here is L into B, that will LB. The top will be also LB. If you talk about the front, then front you can see L, length, length, and the height H. Okay, that means this one area is what? Area will be LH. So back side will be also LH. Okay, so if I ask you that what will be the lateral surface area? Lateral surface area, already we have discussed that the surface is excluding the bottom surface and the top surface. That means two times you are getting BH, front and back two times. Which one? LH. Okay, so two times BH, this left side, right side, front and back. Okay, two time VH, two time LH. If you take two common, two H common, so L plus B, or we can also explain in this way, 2 into L plus B into H. And you see this is the perimeter of the base. This is perimeter of the base. So you can also write down perimeter, okay, into height. Perimeter into height. So this is also formula. Sometime in competitive exam they will say that if perimeter is 20 meter and its height is which one, 10 meter, you find out the uh, lateral surface area. Okay, lateral surface area. So that time it will be perimeter into height, meter square. So lateral surface area will be 200 meter square. You understand me? So this is the concept of using perimeter, lateral surface area. Okay, fine, all right. Yes. Now we will discuss about total surface area. Total surface area. See this, total surface area. So our second point is total surface area. So we have already seen total surface area. Total surface area means these four wall, that means sideways wall, LSA, lateral surface area, plus top surface and bottom surface. Top plus bottom face. Okay, top plus bottom, top and bottom. Okay, so uh, what is top surface area? You see this top is LB and bottom is also LB. That means 2 time LB, right? Now if you put this lateral surface area 2 into length plus breadth into height plus 2 LB, you simplify, you will get it 2 into LH plus BH 2 LB. That means 2 into LH plus BH plus LB. So this is the formula of total surface area. All right, total surface area. So this we have done total surface area, lateral surface area. Now coming to this again, longest rod will be what, or the diagonal will be under root L square B square plus A square. This is diagonal. Okay, in 3D space, not in 2D space. In 2D it will be only root under L square plus B square, but here L square B square plus A square. Okay, in 3D, in three dimensional, three axes will be there: x axis, y axis and z axis. One will represent length, another will represent breadth, and another axis will represent height. That is why three uh, values you have to put, three variable you have to use it. Okay, all right. Next, coming to the volume of cube and cuboid. So volume is very simple. uh, you can memorize or you can understand very easily. To find out the volume, formula is what, it will work 95% cases. That volume is what, volume, can you tell me what is the difference between the volume and area? A student sometimes can't explain it properly. Area means the place occupied by an object. Means if a bottle is on a surface, okay, so it is just taking this much of area, right? Maybe you're a house we say generally that what is the what square feet area? We say 1000 square feet area of the house. So that means your house may be five, may have 5 floors, 7 floor, but the we will discuss basis on the area. Means we will say about, means how much places, how much place it occupied, okay, or how much place the house, your one bottle or one solid figure has occupied, okay. So the place occupied by an object is actually the area, and the space, this is place, 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 and this is space, space, space. For example, the water inside the bottle, okay, water inside the bottle, so this is space, okay, space inside the bottle, the amount of water inside the bottle, that is the what, that is volume. So space inside, space inside my this room, this is volume of the room, okay. So space inside an object, space inside, that time you say better, instead of object you say body, okay. So space inside a body, space inside a body, okay. You don't say figure, figure is generally two-dimensional, okay. So don't say figure, space inside a body is its volume, and the place occupied by an object, okay, is known as its area, okay. So this concept you make it clear that what is area and what is volume, okay. Here you go. Next, so we'll find out the volume. So how to find out the volume? Volume formula is always, in maximum cases I told that it will be area of the base, uh, product of area of the base and height. That means volume will be what, area of the base into height of it, okay. For example, in this figure, if the base is 100 meter square, right, and the height is 20 meter, okay. So volume will be what, volume will be 100 meter square, right, into height is 20 meter, so 2000 meter cube. So you can see this, that area means what, length into breadth. So we can also simplify that area is length into breadth, and this height is what, h. That means volume is what, v is equal to length into breadth into height, length into breadth into height, or you can say area of the base into what, height of it, okay. So volume is actually product of area of the base of a figure and its height. This is known as volume, okay. Chalo. So in case of cube, you tell me now what will be the volume. In case of cube, L, B, H all are means each sides are equal. If its measure is a, so in place of L, B, H, it will be what, it will be, just a second, it will be a into a into a, okay. In that case it will be a into a into a. In case of cube, a into a into, because length, breadth, height all are same, so in that case volume of cube will be what, a cube, length into breadth into height. L is a, b is also a, h is also a, okay. All sides are equal, so length is a, breadth is a, height is also a, so this will be a cube. So this is the volume of cubed. You understand me? Okay. Next, so one just studies again, we will recall the surface area, volume, diagonals and all for cube and cubed, okay. So I have drawn one partition here. This is for cube and this is for cuboid. Sometimes question come that area of the four walls. Okay, so area of the four walls means what? You will find out lateral surface area. If nothing is given, sometimes student become confused that sir, nothing is given. For the question in the question written that find the surface area. So which area will find out, LSA or TSA? So if nothing is given, you remember that total surface area you will find out. And if given the lateral surface, then you will find out lateral surface. If given that find out the area of four walls, area of the four wall, generally in case of whitewashing, question gives that find out area of the four walls, right? So in that case you will find out lateral surface area and you will proceed accordingly. Okay, so first is lateral surface area. Here lateral surface area is what? Lateral, na? Okay, lateral surface area, LSA. Here is LSA. See, lateral surface area, all area of each face is same. So four faces generally sideways, so 4 is square. And here I told perimeter into height. So 2 into, sorry, 2 into length plus breadth, yes, into height. This is for the cuboid. Then total surface area, this is lateral surface area plus top and bottom 6 square, and here 2 into L plus B, okay, plus 2LB, or 2 into LH BH plus LB. All right, okay. Then we discuss about the longest diagonal. Here diagonal will be all a square, a square, a square, and here diagonal is root under L square, B square and A square. So this is root over 3 square, that means root 3A. Here no more simplification. Okay, and number 4th is volume. B is equal to A, length, breadth, height, all are same. A cube, cubic units. Okay, and here volume is what? V is equal to length into breadth into height. We told that area of the base into height of base. Okay, all right. So this is uh, a simple summarized of cube and cuboids, surface area and volume. You can take a screenshot of it. Okay. Next, we'll discuss about cylinder. Fine. Let's see. I will start with again a 3D animation. You can understand it better. Then we will start it. This explanation of area and volume. Fine. Chalo. Okay. So now you can see uh, again a 3D animation of a cylinder. You can see this, that if we deposit if we deposit a bundle of disc, then this type of cylinder will be formed, right? So you can see the top surface and the bottom surface of a cylinder is of disc or circular shape. Okay, and the side ways that surface is actually not the plane surface, this is curved surface. So in case of here two cases will arise: area of curved surface area and total surface area. In the last figure you have seen this, we talk about the lateral surface area. Lateral surface, this word we'll use if the sideways faces are plane faces. Okay, And this curved surface area, what we'll use if the faces, if the sideways face is curved face. Okay, so here curved surface area and total surface area. See this. So two face you can first we'll discuss about the plane, means top face and the bottom face. Okay, then curved surface and total surface area. Fine, so I can highlight the top surface. Yes, this is the top and this is the bottom surface. Yes, you can see this top and bottom, right? Top and bottom. This bottom surface I have taken, color is suppose blue. Yes, the one is blue and this side is green, blue and green. And this lateral surface I will also highlight. Fine, I will also highlight. Lateral surface by red color. Yes, red color. So you can see these three surfaces I have marked. Okay, now we'll discuss about the area. Right, see, this is surface, circular face, so area will be pi r square, and this will be also pi r square, right? And one more things very important, that if you want to find out curved surface area, mind it, curved surface area, in that case it will be perimeter of base into height, just like our previous with the last figure. Okay, height. So you tell me what will be perimeter of the base. This is circular, so it will be 2 pi r, right? And height is what? Suppose it is height is h. Okay, so it will be 2 pi r h, 2 pi r h. So this is curved surface area, 2 pi r h, and these two top and bottom given 2 pi r square. So curved surface area, perimeter into height 2 pi r h, and this is 2 pi r square, right? Now then tell me total surface area will be what? Total surface area will be 2 pi rh, that is curved surface area, plus 2 pi r square, 2 pi r square, that is 2 pi r square. If you take 2 pi r common, 2 pi r into h plus r. Okay, so this is the total surface area of cylinder. I repeat, two circular faces, pi square, that is 2 pi square, and curved surface area is perimeter into height, that is 2 pi rh. So if you combine, you will get total surface area, that is 2 pi rh plus 2 pi r square. Now if you take 2 pi r common, then h plus r. Fine, so this is all about this. Okay, next, coming to the next figure, that is that is uh, cone, then sphere. Okay, another video you will see all types, means problems, different types of problems, and its solution I will explain, and I also provide you some exercise problem that you can practice at home. Okay, so that your surface area and volume chapter will be completely practice. Fine. Okay, now coming to this next figure, that is cone. Okay, so take a cone. Yes, all right. So you can see this is uh, after cylinder, this is cone. Okay, you can see this. So if I ask that how do you get a cone, so answer is that if we take a right angle, and if we rotate the angle along its perpendicular, means along its heights, then we will get this type of cone. Okay, I'm just trying to show you possible. Okay, that if I rotate right triangle, then how a cone will be formed. Okay, just wait. So you can see this, that I have drawn one right angle triangle. Okay, so if a right angle triangle rotate along its perpendicular, means along maybe base or along its height or altitudes, then this type of cone will be formed. As I promised you that I will try to show the things in this digital platform uh, completely. So I hope you are enjoying it. Okay, so let's see the total surface area and the lateral surface area of it. So this is means also my dream, that I cannot see all these things in my life digitally, but since time has come, so I will definitely try you give my 100% to make you understand the whole concept digitally, whether it may be geometry or it may be algebra. Only your help, your assistance I need. Your If you be interested, then definitely I can do many things for you. Okay, if you are interested, then definitely I will try to give my more than 100% in this digital platform to make you understand. Okay, thank you once again for watching, for giving, for sharing your valuable time to understand the concept from this math magic channel. And obviously you will subscribe and like to get this type of nice presentation from math magic and math magician. Okay, so let's let's start again. So you can see this, you can see two surfaces are there. One is plane face, two faces are there, one plane face and another is car face. Again we'll say that plane face is in the shape of what? This is in the shape of circle, right? So since it is shape of circle, so its area will be what? Pi is r square. And in this case only one plane face only, right? And another is lateral surface, curved surface area. Since here the radius of the base, suppose it is 10 centimeter, right? Here you will get the base will be what? Less 8. Here will be also one circle, understand? Again one circle here. So gradually the length of the radius is decreasing. Okay, so it is decreasing, understand? So since the radius is not uniform throughout the height, that is why you cannot take this curved surface area right now 2 pi r h, you can't take this. Okay, so in this case formula will be little bit different, and if you want to find out, then you have to use the integration formula to get it. But I'm trying to make you understand. Here you can see one right triangle. So two types of heights are available here. Two types of height. One is this is called height, and this height called this called slant height, denoted by suppose a, it's called slant height. Slant height, this is tilting making angle, suppose theta, so this is called slant height. Find slant height L. And if it is radius, then tell me what will be the value of L. So value of L, you can see this is just like a right angle triangle. So it is hypotenuse, so it will be root over a square plus r square. So L is equal to a square r square. So what will be the curved surface area? This will be, this time this will be pi r L, not 2 pi r h, pi r L. So what will be total surface area? You can see this. So this time pi r L, two surface, two heights, one is slant height L, another is height, and this is slant height. Fine, this is the slant height. All right. So what will be total surface area? Total surface area will be curved surface area, that is pi r L plus this base pi r square. If you take pi r common, then L plus r. All right. So final formula is what? This is pi r plus. You can memorize in this way, in split form. So curved surface area pi r L, and area of the base pi r square. Right. So this is pi r L plus pi r square. Now common part anytime you can take. I will recommend that you don't memorize this. Okay, this is my suggestion. You will write down whatever you can understand from the figure. Okay, that curved surface area and one base, circular base, so pi r square plus pi r L here, because this, again I'm telling you that this circular form is not evenly spread, right, throughout the height. Sometime radius is 8, sometime radius is 5, somewhere tail, and at the top of this you can see this is a point, right? Point means radius will be just near equal to 0. Okay, so this is not evenly spread, radius is not evenly spread, that is a pi r L formula. Okay, so this is total surface area of what? Cone. All right, one more thing is left in standard 9. This is a sphere. Okay, and in sphere we'll also discuss about the hemisphere, and the sphere and the hemisphere, two cases are there, so we'll explain one by one. Okay, here you just look at the figure. Okay, so you can see the here is one sphere, right, and this 3D plane divide the sphere in two parts, two halves. These halves are called the hemisphere. Hemisphere. Okay, it's called hemisphere, and whole is sphere. Now, if I ask that how a sphere will be formed, a sphere will be formed if we draw one circle, if we rotate a circle along its diameter, then we will get this type of sphere. You can try, you will take a stick and you will paste one circular disc and you rotate along the stick, you will get this type of sphere. Understand? So here only one uh, face you can see, that is the curved surface area. Here curved surface, whole surface is curved surface, right? So here curved surface area and the total surface area will be same, only one surface, curved surface and total surface area, both will be same. Okay, so let us discuss. So you can see this. Now this is one sphere is here, This is the circle at the middle. So here total surface area and curved surface area both are same. Okay. Formula is what? Formula is 4 pi r square. Okay. This proof you can do, you can show using the taking the help of integration. Okay, a small area you have to take, and you have to take the range minus r2 plus r. So this is a concept of higher classes. One, if possible, once I will show you. Okay, in class 11 videos. Okay, but not in class 9 video, 9 class video. Okay, so that if possible I will show once. So right now you will memorize the formula, that is 4 pi r square. This is total surface area. Or in different way we can also, I can also explain you that, as I told, this is perimeter into height. So you see once perimeter into height. Okay, so perimeter is 2 pi r, right? And here length is, height is what? This is r and this is r. That means diagonal is 2r, diameter is 2r. So you multiply 2r, so you can see 2 to the 4 pi r square. So these 2 pi r and r, 2r. This perimeter and height is just working as height is equal to the diameter 2r. So 2 pi r into 2r will be 4 pi r square. In this way we can also memorize right now that curved surface area or total surface area is what? 4 pi r square. But actual for values can be found by using the concept of integration, which will get in standard 12. Okay, so this is curved surface total. Now volume, what will be the volume of a sphere? Volume of a sphere will be what? 4 third pi r cube. Again by integration you will get this 4 third pi r cube. Now we will discuss about a hemisphere, half. In case of a hemisphere, you cannot say curved surface area. There are two cases arise: curved surface and total surface. Curved surface will be half of this 4 pi. It will be 2 pi r square, because total is 4, so this is half of it. Okay, so that is 2 pi r square, and this is pi r square. Okay, so in this case, in this case this is curved surface area, CSA, and total surface will be different. Total surface will be what? This curved surface area 2 pi r square. This is hemisphere. Okay, hemisphere 2 pi r square plus 1 pi r square. So in this case, total surface area will be 3 pi r square. Very interesting. Total surface area 3 pi r square and curved surface is 2 pi r square. This is for hemisphere. You understand me? Okay. And volume will be half. Here is 4 third pi r cube, and here will be 2 third pi r cube. This is volume for hemisphere. Okay, so total surface area 2 pi r square plus pi square 3 pi r square, and volume will be just half. For example, if you have one ball, okay, one football you have, fine. If you cut into two pieces, then if inside the football means in the, if 4 liter water can be placed inside the football, then in the half portion of it 2 liter will be kept. Okay, so volume will be exactly half of the volume of the hemisphere will be exactly half of the volume of the sphere, that is half of 4 third pi r cube, that is 2 third pi r cube. There is no changes. But in case of total surface, it will be 2 pi r square plus pi r square, because this surface coming extra, right? So that is why 3 pi r square. All right, this is all about volume, surface area. Now one more things I will explain. This is for if the sphere is hollow sphere, hollow cylinder, in that case what will happen? For example, if you have hollow cylinder, okay, hollow cylinder, you have hollow cylinder, all right. In that case, two you will get two radii. One is inner, another is outer. This is suppose form of metal. Inside portion is hollow, this is metal. They sometimes ask in the question what will be the mass of the what will be the mass of this mm, metal. So in that case, right, in that case you have to apply this formula. Maybe suppose hollow cylinder. I promised you that I will explain the concept in a realistic way. Okay, sure. So this is, you can see this hollow sphere, right? So nice. Really, I'm very thankful to this digital platform. I don't know how much you are liking these things, but I'm very much happy that I can have the opportunity to nurture all these things. Okay, so to find two radii, you can see small r and capital R. Okay, so what will be the, in that case you have to find out this area of the ring. So one is, you can see the capital pi r square. Okay, capital pi r square, capital pi r square, pi capital R square, and if you subtract the inner circle, pi small r square. Okay, this is now area of the base. I told volume will be area of the base, so area of the base is pi capital square minus pi small r square, and height is suppose h right now also. So now area will be this pi capital square minus pi small r square into, you can simplify pi common, r square minus small r square into h. So this is pi into r plus smaller r minus smaller into h. So this can be also the formula for hollow sphere. Okay, now I will show this volume. A surface area will be different. Surface area one will be for the outer part, that is 2 pi r h, and inner part 2 pi smaller h. Their sum will be the total surface area. Okay, and the ring is also there. Ring is 2 into pi capital R square minus pi small r square. So that will be the surface area. Okay, I repeat, one you will get for the outer, that means 2 pi capital R h. Another will be for the inner, this wall, and outer wall. This is outer wall, this is inner wall, 2 pi r h, plus this ring you will get, ring is this one, 2 times bottom and the upper. So 2 into pi common r square minus small r square. What is this? This is total surface area of hollow cylinder. Okay, this is very interesting. You will be confused. Okay, so one is for the, I repeat, one is for outer surface, that is 2 pi capital R h, as you know this, and another is for inner, 2 pi smaller h, and ring pi capital R square small square 2 times. Okay, inside portion is vacant. Fine. So this is the case, very interesting. Once again, the for this hollow cylinder sphere I will show, then I will close this explanation chapter, explanation part. Next part will be only the discussion about the numerical part. Okay. So here you can see that one smaller, again capital R. So what will be the volume? Tell me. Volume of the bigger sphere minus smaller sphere. That means 4 third pi capital R cube minus 4 third pi small r cube. This will be the volume. Okay. If it is hemisphere, if it is hemisphere, hollow hemisphere, okay, in that case volume will be just half of it, just half of it, just half of it. Problem will be in case of surface area. Fine. So in that case, in the hollow case, surface will be also same type of things. One will be for outer and one will be for inner, and this one. Okay. That means in that case it will be what? You know this 2 pi capital R square. That was 4 pi square, so 2 pi capital R square. And for the inner, it will be 2 pi small r square, and this above part. Only one time pi capital R square minus small r square. This is the total surface area. Alright. If you say curved surface area, then only this much will be curved surface here. And if you talk about the total surface, then this will be included. Okay, very nice things. Okay, I hope all of you have understood. Fine. Once we'll review the whole formula, then we'll say tata goodbye. Okay. So here you can see the formulas, all the formulas at a glance. Okay, let me summarize. The first one, total surface area 2 into LH BH and LB, volume LBH. Here H is lambda they have taken. Diagonal L square B square H square. Area of the four walls 2 into perimeter into heights. Okay, and then for cube 6 square A cube and root 3A. And for this height of the cylinder, area of each end is pi square, curved surface area 2 pi h, total 2 pi h plus r, volume pi square h. Okay, here in case of cylinder, this is pi square base area and height is h, so volume is equal to pi r square h. All right, fine. Next is you have seen this hollow circular, this curved surface area, hollow circular 2 pi r plus this. Okay, and this is total surface area. Total surface area will be this. If you break it, you will get all these things. Okay, and then volume of material, that means whatever material used, that is pi r square h minus pi volume, bigger and minus smaller. Bigger is pi square h, okay, and the smaller is inside interior cylinder is pi. So if you take common pi square, you will get pi r square h minus pi h common, sorry, pi h common, pi h common, so you will get capital square minus small r square. Okay, you can see this here. All right, sure. Next is what? Next is right circular cone. I told slant height root over L square plus H square, curved surface area, total surface area pi r square plus pi r l. Okay, this is one is, this is pi r l and this is pi r square. That is your total pi r square pi r l. The volume done. And this is surface area of this what? Sphere. Pi 4 pi square, volume 4 pi square. Oh, one more thing here I want to explain. Here they have not taken the area of this upper part. But it is they have taken this is negligible. They have only taken the interior and exterior. Okay, but this ring will be also taken pi capital R square minus pi small r square. One will be here, another will be another ring here. Okay, so two times of this must be added with this. Okay, in case of total surface here, total surface, this part will be added. You have seen that I explained in the video. Okay, so all right, thank you so much. I hope you have understood all the things very nicely. Thank you so much for giving your time to me, to Maths Magician, Math Magic channel. Okay, have a nice day. Thank you.